Hello students, welcome to my channel chemistry.das. ఈ వీడియోలో బోర్స్ థియరీ ఆఫ్ హైడ్రోజన్ ఆటమ్ గురించి తెలుసుకుందాం. ఈ బోర్స్ థియరీ ఆఫ్ హైడ్రోజన్ ఆటమ్ అనే దాంట్లో మెయిన్గా ఏంటంటే 3 ఎక్స్ప్రెషన్స్ ఉంటాయి అన్నమాట. అంటే 3 డెరివేషన్స్ ఉంటాయి. ఆ 3 డెరివేషన్స్ ఏంటంటే ఒకటి రేడియస్ ఆఫ్ ది nth ఆర్బిట్. నెంబర్ 1 ఈజ్ రేడియస్ ఆఫ్ ది nth ఆర్బిట్. తర్వాత నెంబర్ 2 వచ్చేసి ఎనర్జీ ఆఫ్ ది nth ఆర్బిట్ అండ్ నెంబర్ 3 వెలాసిటీ ఆఫ్ ది nth ఆర్బిట్ అనమాట. ఓకే, ఒకటి ఏంటంటే రేడియస్ ఆఫ్ ది nth ఆర్బిట్, రెండవది ఎనర్జీ ఆఫ్ ది ఎలక్ట్రాన్ ఇన్ ది nth ఆర్బిట్, మూడవది ఏంటంటే వెలాసిటీ ఆఫ్ ది ఎలక్ట్రాన్ ఇన్ ది nth ఆర్బిట్. ఒకసారి మరి ఈ వీడియోలో రేడియస్ ఆఫ్ ది nth ఆర్బిట్ గురించి చూద్దాము. దానికి ఎలాగా అంటే ఆ ఫార్ములా ఎలా డిరైవ్ చేస్తారు. చాలామందికి ఏంటంటే ఇట్లా ఈ ఫార్ములా డిరైవ్ చేయడం అనేది చాలా టఫ్గా అనిపిస్తూ ఉంటుంది, కానీ చాలా సులువు. ఒకసారి జాగ్రత్తగా ఉంది. ఫస్ట్ లెట్ us టేక్ హైడ్రోజన్ ఆటమ్. మనం ఒక హైడ్రోజన్ ఆటమ్ తీసుకుందాం. హైడ్రోజన్ ఆటమ్కి న్యూక్లియస్ ఉంటుంది కాబట్టి దిస్ ఈజ్ ద న్యూక్లియస్. The charge of the nucleus equal to Ze. What is the charge of the nucleus here? Ze. And this is the hydrogen atom containing only one orbit. And in this orbit, just one electron is revolving. One electron is revolving around the nucleus. What is the charge of this nucleus? Ze. And here one electron is there. That electron is revolving around the nucleus. So the charge of the electron equal to minus E. But the charge of the electron minus E. Next, and this electron having a mass, so mass of electron equal to m. Next, this electron is revolving with a certain speed or velocity. Okay, that is nothing but v. Let us take v. Here actually this is the tangential velocity. What is this one here? Tangential velocity. Okay, anyway, so here velocity of electron equal to velocity of the electron. Which electron? Revolving electron equal to v. Okay, so next, charge is there, mass is there, velocity also we find. So here when this electron is revolving around this nucleus having plus charge and electron having the negative charge, when this electron is revolving around the nucleus, what happened? So there are two forces are acting on this. Electron. Number 1 is okay, and one more thing is from the center of the nucleus to this electron, the distance between the center of the nucleus to this electron is that is nothing but radius r. So this is the radius. Okay, from the nucleus to electron is r. So now there are two forces are acting on this electron. Okay, number 1 is centrifugal force, and number 2 is centripetal force. So where is the centrifugal force is acting and where is centripetal force is acting? Let us find out. Okay, centrifugal force, generally that formula is mv square by r. Okay, Centripetal force, we can find the centripetal force by using only by using Coulomb's inverse square law. Inverse square law. Coulomb's inverse square law. Okay, so one is centrifugal force and second one is centripetal force. Centrifugal force, so it is always acting. Okay, this centrifugal force is acting out of the nucleus, means it is away from the nucleus. It is acting away from the nucleus. Its value equal to centrifugal force mv square by r. And next here, this nucleus is attracting this electron towards itself. It is called centripetal force or electrostatic force. Here nucleus is attracting this electron towards nucleus. That is called centripetal force or electrostatic force. Now, here centrifugal force and centripetal force both are equal. Both are equal. Now, let us find the centripetal force. Centripetal force equal to as for the Coulomb's inverse square law. What is the Coulomb's inverse square law? Q1 into Q2 by R square. The same manner here, this is the Q1, this is Q2. Charges, two charges are there now. So I am writing here ZE into, there is a nuclear charge, okay, into second one is minus E by R square according to the Coulomb's inverse square law. Coulomb's inverse square law. Next, so when you can write like this one, Z minus Z E square by R square. Can you write like this? Minus Z E square R square. This is centripetal force. Now equate these two. Why? Because these two forces are equal and opposite. Okay, so now I am equating these two, centrifugal force and centripetal force. That is M minus, first this one, centripetal force, minus Z E square by R square equal to minus mv square by r. Okay now. Next, so we have to bring that v square one side and the remaining other side, then we will get that v square equal to minus minus cancel. So v square is there now. Keep this v square one side and remains and this mr that side. Then what happened? It reverses that ze square into r by, then what happened? M into r square. M into r square. So this r, and r square cancelled. R and r square is cancelled. Then what happened here? V square equal to z e square by mr. This is the equation 1. So we know that according to the Bohr's quantization rule, quantization means angular momentum is quantized. So according to Bohr's quantization rule, what happened? According to Bohr's quantization rule, we can write that mvr equal to nh by 2 pi. This is the pi. mvr equal to nh by 2 pi. From this we have to take only v. Okay, just I am separating the v equal to what happened? It become nh by 2 pi mr. Okay na, V equal to nh by 2 pi mr. But we want V square. Why? Because here in this V square is there, so that's why squaring on both sides. Squaring on both sides. Then what happened? V square equal to, then what happened here? N square h square by 4 pi square m square r square. So this is the equation number 2. Okay now. So equate these two equations. Why? Because v square equal to z square by mr. Here is v square equal to n square h square by 4 pi square m square r square. So when you equate these two, what happened? V square equal to how much here? First we have to do the v square equal to ze square by mr. This is the first one. Next, another derivation we got here, v square equal to n square h square by 4 pi square m square r square. Okay, actually we got these two. Okay na? So now we equate this 1 and 2. Then what happened here? So you can write z e square by m r equal to n square h square by 4 pi m square r square. Now bring, let me do one thing. Z square, take cross multiplication, z square into 4 pi m square r square equal to mr into n square h square. Then I want only r square here. I am sending this r this side. Then what happened? M n square h square by z e square 4 pi m square is there. Now r and this r square cancel here. Next, what cancel here now? Okay, only one m is there. Here m square is there. This cancelled. Anything? No, only this. So finally you will get that r square by r equal to n square h square by next 4 pi m z square. Okay, this is our final formula for the radius of the nth orbit. Okay na? So r equal to n square h square by 4 pi m z square. So this is the radius of the nth orbit. We can write here Rn also. So Niels Bohr successfully calculated the radius of the nth orbit by using this formula. Okay na? So next. So in this formula, Rn equal to n square h square by 4 pi square m z square. So in this formula there are some constants are there. What are the constants here? Rn equal to h is constant, so h square by 4 is constant, pi is constant, and m also constant, and e square also constant. What is h here? Here h equal to Planck's constant. H equal to Planck's constant. And next one is m is the, what is m? Mass of the electron. What is the E? Charge of the electron. Okay na? So it is the charge of the electron. Now actually this Rn equal to h square by 4 pi square m e square. This is the constant, and remain what left here? Here n square left. N square by down z is there. Okay, this became actually constant. Okay, now this became, it is the whole became the constant. Then I will write like this. So after calculating the values, so h value, substitute the h value and pi value, m value, e value, we will get that Rn equal to 0.529. This total value is become 0.529 angstroms. 529 angstroms into n square by z. This is the final formula. This is the final formula. Okay, now? So like this. So by using this formula, we can calculate the radius of the nth orbit. Okay, let us take one problem. Okay. I'll give that one problem. Find the radius of the Bohr's second orbit. Okay, now find the radius of the Bohr's second orbit. Let us take. Find the radius of the Bohr's second orbit. Okay, Bohr's second orbit. So how to find it? For example, you know that. So Rn, this is second orbit for hydrogen. Hydrogen. Okay, now find the radius of the Bohr's second orbit for the. So instead of this one, we will take the helium. Helium ion. Okay, then Rn equal to 0.529 into, for helium actually n, this which orbit you are asking, second orbit, no? So second means 2 square, but for helium atomic number equal to 2. Helium atomic number equal to 2. So then you can write this this one 0.529 into 4 by 2. 2. So this 2 and 4 2 times. Then what left here? So 0.529 into 2, that is 0.529 into 2, that is equal to, you will get 18, 5, 10, so 1.058. 1.058 angstroms. So like this we can calculate. Okay. So this is the final, what is that final formula? Rn, radius of the nth orbit, equal to 0.529 angstroms into n square by z. If it is only for hydrogen, first orbit means this is not required. Why? Because for first hydrogen, z equal to 1. First orbit n square means 1. 1 cancel. Then you will get only 0.529. Okay, same. Now what happened? As per this, so radius of the orbit, okay, or shell radius of the any orbit is directly proportional to n square. What is this meaning? What is meaning? As the shell number increases, shell number increases, అంటే షెల్ నెంబర్ పెరిగితే ఏమవుద్ది మనకి, రేడియస్ ఆఫ్ ది ఆర్బిట్ కూడా, అంటే ఆర్బిట్ యొక్క రేడియస్ ఆల్సో ఇంక్రీజెస్. ఓకే, తర్వాత ఇంకేం చెప్పొచ్చు, ఆర్ ఈజ్ ఇన్వర్స్ ప్రొపోర్షనల్ టు జెడ్. ఓకే, ఆర్ ఈజ్ ఇన్వర్స్ ప్రొపోర్షనల్ టు జెడ్. యాజ్ ద అటామిక్ నెంబర్ ఇంక్రీజెస్, radius is decreases. So like this, these are the relations here. So like this we can find that radius of the nth orbit.